A very good morning to all of you. I once again welcome you all to this current video lecture. In the last video lecture, we studied one important point from the syllabus, that is the methods of determination of this energy of activation, or how to determine this energy of activation. After that, we solve some simple numericals for calculating this energy of activation in calories and in kilocalories. Now, in continuation to the same point from last video, that is a numerical solving, today we are going to take some more numericals on another point. So, today we are going to take some numericals for the calculations of the order of a chemical reaction. How to calculate this order of a chemical reaction. So, for this purpose, we studied the 4 different methods. So, among that 4 different methods, the 2 important methods are there. That is called as the half-life period method, or it may be called as the fractional change method, and the second method is called as the differential method. So, by using that 2 methods, we may calculate the order of a chemical reaction. So, for this purpose, today we are going to take these 2 different numericals for calculating the order of a chemical reaction. So, first of all, we are going to take this first numerical. So, for this purpose, some reaction is given. So, in this case, what is there? So, this is one gaseous chemical reaction in which 2 moles of HI get converted into H2 plus I2. 2 moles of HI get converted into H2 plus I2. So, for this purpose, some conditions are given. So, what are that conditions? So, in a given tabular form, initial concentration in a mole per liter and respective half-lives are given. So, if the initial half-life, 2 different half-life is there, as well as 2 different initial concentration is there. So, by using these 4 different parameters, we have to calculate order of this particular gaseous chemical reaction. So, what is there? 2 different initial concentrations are there. First is a 5 mole per liter, second is a 20 mole per liter, and the first half-life is a 20 hours and second half-life is a 10 hours. So, we have to calculate, or we have to determine the order of a chemical reaction. So, for this purpose, we have to write here first given. What is given? So, that we have to write first of all. So, first of all, we have to write here given data. So, what is the given data? They give us the half-life period first, then half-life period second. So, what is the half-life period first? It is already given here. So, half-life first is a 40 hours and second is a 10 hours. So, just we have to write that T half first is a 40 hours and T half second is a 10 hours. This is a first initial. After that, they gives us the initial concentration. 2 different initial concentration is there. First is a 5 mole per liter and second is a 20 mole per liter. So, just we have to write that. So, this is a A1 is equal to 5 mole per liter, 5 mole per liter, and the second initial concentration is a A2 is equal to 20 mole per liter. So, these are the 4 different parameters are given for calculating this order of reaction: T half first, T half second, A1 and A2. Once we obtain this particular given data from this particular tabular data, then next duties we have to take some suitable equations for solving this particular numerical. So, we know one equation from the half-life period method to calculate the order of chemical reaction. And what is that? Order of a chemical reaction. This is the order of reaction. Order of reaction, that is nothing but the small n is equal to, that is a small n is equal to, it is a 1 plus log of T half of first minus log of T half of second divided by log of A2 minus log of A1. So this is the equation from the method called as the half-life method to calculate the order of a chemical reaction. That is the order of reaction small n is equal to 1 plus log of T half minus log of T half 2 divided by log A2 minus log A1. Next we have to substitute the values from the given data. So what is it? So n is equal to, it is a 1 plus log of, what is the T half first? It is a 40. So log of 40 minus log of, it is a 5. Sorry. We have to take first half-life period. So what is the half-life period first? It is a log, first half-life period is a 40. Okay, so first half-life is a 40. Second half-life is 10 hours. So minus log 10 divided by what is the A2? A2 is a 20. So it is a log 20 minus log of, first A1 is a 5. So it is a log 5. So just we substitute the values from given data. So it is a 1 plus log of 40 minus log of 10 divided by log of 20 minus log of 5. Now if I substitute the values for this log, what is it? So it is a n is equal to again 1 plus, this log 40 comes out to be 1.6020. It's a 1.6020 minus log 10 comes out to be 1.00. It's a 1.00 divided by this log 20 is there. What is log 20? It is a 1.3010. 1.3010 minus log 5 comes out to be 0.6990. 0.6990. Now if we substitute all these log of values for the given data, finally we get a value for this n. So if we solve these total terms, then finally the value for this n comes out to be n is equal to, so the value for this n comes out to be, after solving this total equation, the value of n comes out to be equal to 2. The value for n comes out to be equal to 2. So we can say that the order of the particular chemical reaction is equal to 2. So this is a very simple numerical based upon the data given of in terms of half-life period and the initial concentrations. So to solve these particular numericals, first of all we have to write the given initial data in terms of half-life period, in terms of two different initial concentration. After that we have to take a suitable equation from the half-life period method, that is a 1 plus log T half of 1 minus log T half of 2 divided by log A2 minus log A1. Then if we substitute the values, the order of chemical reaction comes out to be equal to 2. So we can say that this gaseous reaction of conversion of 2 moles of HI into H2 plus I2 is a second order chemical reaction. So this is the first simple numerical. Now once we solve this first simple numerical, now we have to take the second different type of numerical for the calculation of order of a chemical reaction. So for this purpose, the chemical reaction is given the 2 moles of NO plus Br2, it gives the 2 moles of NOBr, that is a nitrosyl bromide is obtained. Now during this reaction, during this conversion, what happens? The concentration of NO and rate. How to correlate this concentration of NO and rate? For this purpose, some data is given in a given table. So what happens? The concentration of NO, if we change the concentration of NO, it affects the rate of a particular chemical reaction. So two different conditions are given. If the initial concentration of NO is equal to 1, the rate of a chemical reaction is equal to 1. But if we change the concentration of NO, for example, if we change the concentration of NO equal to 2, means if we doubles the concentration of NO, then what happens? The rate becomes 4 times of that of the initial concentration. If such a type of reaction condition is there, then what is the order of a chemical reaction with respect to this NO, that we have to calculate now. Okay, so this is a simple difference between the first numerical to that of the second numerical. What is the difference? In a first numerical, No doubt initial concentrations are given. In this case also initial concentration is there, but the second parameter get changed. In this case half-life period is given, but in this second case the rate of reactions are given. So for this purpose we have to use a suitable equation. First of all, we are going to write the given data. So what is the given data is there? So two different type of the given data is there. First is the initial concentration of NO. So what is the initial concentration of NO? First initial concentration of NO is, for example, A1. First initial concentration of this NO. So what is it? It is equal to the 1. First initial concentration is equal to 1. At that time, what is the rate of a chemical reaction? That is the R1 is equal to. That R1, that is the rate of a reaction. When initial concentration of NO is equal to 1, that R1 is equal to again 1. So we write here simply 1. After that, when we change the concentration of NO, that we make it double, then that is the second concentration. We write it as a concentration of A2 is equal to 2 now, and respective rate is called as the R2, it is equal to the 4. So this is a simple given data from this given chemical reaction to calculate the order of a chemical reaction. Once you obtain this given data, the next job is to take a suitable equation to calculate the order of a chemical reaction. Now, what is the equation for solving this numerical? So again, this numerical is based upon the next method for calculating the order of a chemical reaction, and that is called as the differential method. So according to differential method, the order of a chemical reaction, order of reaction, that is a N is equal to, that is a N is equal to. Now this order of reaction is with respect to this NO. So we have to write here with respect to NO. We have to calculate this order with respect to NO, that is equal to. So what is that equation? There is a next equation based upon the differential method. So what is that equation? So that equation is your log of R1 minus log of R2, log R1 minus log R2 divided by log of A1 minus log of A2. So this is a next equation we have to use here for solving or for determining the order of a chemical reaction. So this equation is based upon the differential method. The next job is only we have to substitute the values from a given data. So in the next step we will get here N is equal to log of this R1. What is R1? R1 is equal to 1. So log of R1, that's log of 1 minus log of 4 divided by, what is the value for this log A1? It is a 1, and for log for A2 it is equal to 2. So we can write here log 1 minus log 2. So just we substitute the values from a given data. Now if we take a suitable particular value of logarithm for all these terms, finally we get the value for N is equal to, if we solve this numerical, then finally we get the value for N is equal to 2. So we can say that the order of reaction with respect to this NO is equal to 2, or this is a second order reaction with respect to this NO. So this is a second type of the simple numericals based upon the suitable equations, one based upon the half-life period and second is based upon the differential method, or depending upon the rate of a particular chemical reactions. So by using this type of the simple equations, we may calculate the order of a given chemical reactions. So these are the two simple numericals to solve the order of a chemical reactions. Now suppose this is a chemical reaction, we calculate the order of a reaction with respect to only one of these reactant, that is the NO. Secondly, if we want to study now, what if we change the concentration of second reactant? If we change the concentration of second reactant, for example, now what is there? If we change the concentration of second reactant, for example, it is a Br2. This is a Br2 second reactant is there. So we can simply change here concentration of Br2. Now if we change the concentration of Br2, then what happens? If we change its concentration, first initial concentration is 1, if we doubles the concentration of this Br2, then what happens? Its rate becomes doubles, its rate becomes doubles. So this is a second type of method to calculate the order of a reaction with respect to now Br2. We have to calculate this order with respect to Br2 now. So just we have to change some given data. So what we have to change here? If we doubles the initial concentration of Br2, then what happens? Its rate become doubles as compared to the initial rate. So at that condition, what is the order of a chemical reaction, that we have to calculate now. So just I erase it. Just I erase this. Now again we have to change this given data as well as the their particular values. Now, if we look towards the table, this is the second type of the problem based upon the same chemical reaction. Calculate the order of a chemical reaction in terms of now Br2, that is a bromine. We have to calculate its order. Now, what happens? If initial concentration becomes double, its rate becomes doubles. At that condition, what is the order of a chemical reaction? So, for this purpose, again we have to solve the same equation. Before that, we have to write the given data. What is the value for initial concentration? So first of all, the first initial concentration is A1. What is the value for that? It is equal to again 1. So we can write here concentration of A1 is equal to 1. At that time, what is the rate of a particular chemical reaction? Again, it is equal to the 1. Secondly, if we doubles the initial concentration of this Br2, if it doubles, then what happens? Concentration of A2 is equal to 2. At that time, what is the rate of a chemical reaction? It also get doubles. So again, we have to write here rate R2 is equal to 2. Now, by using this type of the given data, again we have to substitute these values again in the same equation. But now we have to calculate this order of a reaction N with respect to now Br2. So just we have to change here with order of reaction with respect to Br2. Just this is a simple difference. After that, we have to just substitute the values for A1, A2 and R1 and R2. So again, our equation is a N is equal to log R1 minus log R2 divided by log A1 minus log A2. Now, if we substitute these values, so it comes out to be log of, again R1 is equal to 1 minus R2 is a log of 2, log A minus log 2 divided by log 1 minus log is a 2. So just we substitute these values. Now if we solve this simple equation, finally we get the value of this N is equal to. So finally we get the value for this N is equal to, if we solve this particular equation, after that the final value comes out to be is equal to 1. This value comes out to be equal to 1. So we can say that order of reaction with respect to this bromine is equal to 1, while with respect to this it comes out to be 2. So this is a simple method to calculate the order of a chemical reaction with respect to any one of the reactant of a particular chemical reactions. So in the today's video lecture, just we studied the two important numericals to solve the order of a chemical reaction by using the suitable methods. Now remaining numericals I will give you in the form of a notes. So with this, today we completed the all the important points from a given chapter. So in a next upcoming video, we will start the next chapter from your syllabus. So with that, today I stop here. Thank you.